Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial, we're going to use Euclid's division lemma to write the greatest common denominator of 15 and 22 as a linear combination of those two numbers. Now, before we get started, make sure to subscribe to the channel for notifications on more math tutorials. All right, now let's take a look at this example. Our example says, write the greatest common denominator of 15 and 22 as a linear combination of 15 and 22. And let's go over a couple of things before we get into the computation. First of all, we're being asked to write a linear combination, so our final answer should be in the form of the greatest common denominator set equal to 15 times some number plus or minus 22 times some number. The second thing to note is that there are no common prime numbers between 15 and 22, right? 15 is 3 times 5 and 22 is 2 times 11. So there's no common prime numbers that relates 15 and 22, and therefore the greatest common denominator of 15 and 22 is 1. So this means that our linear combination will be written as 1 equals 15 times some number plus or minus 22 times some number. Now the last thing that we'll review is Euclid's division lemma itself. It says given positive integers a and b, which for us is 15 and 22, there exist unique integers q and r, which are the quotient and the remainder, such that a equals b times the quotient plus the remainder. So let's start our solution off by plugging in 15 and 22 for a and b. So we've got 22 equals 15 times a quotient plus a remainder, and note that 22 over 15 gives us a quotient of 1 and a remainder of 7. So we can rewrite 22 equals 15q plus r as 22 equals 15 times 1 plus 7. Now we'll take 15 and put it on this side of the equal sign. It has become our new a. 7 will become our new b. And we'll multiply that time a quotient and then add the remainder. Now note here that 15 over 7 gives us a quotient of 2 and a remainder of 1. So we can rewrite 15 equals 7q plus r as 15 equals 7 times 2 plus 1. And this is good because the remainder should reflect the greatest common denominator, which of course it does. We found earlier that the greatest common denominator of 15 and 22 is 1, so this is correct. Now earlier we said that the final answer should be written as the greatest common denominator, which for us is 1, set equal to 15 times some number plus or minus 22 times some number. So our next step is to rearrange 15 equals 7 times 2 plus 1 to get 1 by itself on one side of the equal sign. To do this, we'll just subtract 7 times 2 from both sides, and that'll leave us with 1 equals 15 minus 7 times 2. And again, we need 15 times some number and 22 times some number. We've got 15, but we need to find a way to introduce 22 back into this equation. So I'm going to revisit 22 equals 15 times 1 plus 7. If I subtract 15 times 1 from both sides, I end up with 7 equals 22 minus 15 times 1. And I can plug this in for our 7. So I'll rewrite this as 1 equals 15 minus 22 minus 15 times 1 times 2. 15 times 1 is just 15, so I'm going to simplify this a bit. And then I'll distribute the 2. So we're really close here. We see that we have 22 times some number, which at this point is 2. And notice how we have 3 15s here. We've got 15 times 2, and then we've got a standalone 15 as well. So we can combine these 15s to get 15 times 3, and then minus the 22 times 2. And this is our linear combination. And there you have it. We've written the greatest common denominator of 15 and 22 as a linear combination of those two numbers. If this video was helpful for you, give it a thumbs up, like the video, and also subscribe to the channel for notifications on more math tutorials. I'm Coach T, and thanks for watching the numbers game.